Hey guys, oh my God, I cannot believe that you guys have been out of school for 3 weeks now. This is a little crazy, but we are going to get back to how we have been learning. Yes, we are going to be learning new content until we get back to school, which we're aiming for mid-May. So we're going to go back to our lovely YouTube lectures. Okay, and so this is going to be the start of Unit 4. Things are going to be a little bit different. Instructions have already been given via Canvas, so please keep an eye on that. But let's start on today's lecture. All right, so on your screen, you see a little bit of craziness happening. I love this GIF, whatever it's called. Okay, so we see a chemical reaction happening right now. Okay, I'm a little upset you guys were going to be able to do this in class too, but at least you get to see it on your screen. All right, so you see some hydrogen peroxide dish soap, food coloring going in this tube, and then when the person adds potassium iodide, right, it no longer becomes this liquid mixture, right? It becomes this thing that looks like foamy toothpaste, okay? And it propels upward and kind of has this explosion effect, all right? And so this is going to be the generalization of what chemical reactions kind of are going to look like and the basis of what we're going to be learning this unit. And that is all about physical and chemical changes and the types of chemical reactions. All right. So today's objective is you are going to be able to identify indicators of chemical and physical changes. That's what this lecture is all about. Okay. So if we look at changes, okay, if you guys don't know, oh, there it is again. You know that that's going to happen every once in a while. If you know that song, I'm dating myself right now. It's fine. We'll move on. Okay. If you guys already know this, great. If not, write it down. Okay. But we have two types of changes that can occur when we're talking about matter. And we know matter is anything that has mass and takes up space. Okay. These two types of changes are physical changes and chemical changes. All right. We have examples on this side over here, right? Physical is substance is not changed. My size or my shape can change. My state, so whether it's like solid, liquid, or gas, it dissolves. You can bend it, crush it, mix it, cut it, right? Or you could have a chemical change, fizzing, foaming, heating, okay? Produces sight, light, odor, sound, okay? And that change cannot be undone, okay? So it's something completely new, right? So this is the formal definition of a physical change, okay? There is a difference in appearance, size, or display without changing its composition, right? So meaning I start and end with the same substance, okay? If I had a piece of paper and I cut it in two, it's still a piece of paper. If I have water and I put it in the freezer, it becomes ice, but it's still going to be water because I can remelt it, right? So it's the same thing. So these are physical changes, okay? It's the same thing at the beginning and the end. It just might change how it looks, okay? A chemical change, though, is a change in the composition. So it's actually changing, okay? Starting and ending are different substances, okay? And usually this is irreversible, meaning I cannot change back, right? If you think about it, if I burned a piece of paper, I can't get that piece of paper back, right? If something is rusting, right? If milk goes sour, okay? These are all types of chemical changes. And chemical changes, okay, happen due to chemical reactions, okay? And chemical reactions have two parts. There's the reactants, okay? Something, my starting substances, right? Something that is going to undergo the reaction. It's what I'm starting with. And I have my products or my new substances that are going to be formed, right? What I'm ending with, okay? So reactants, what's reacting? Products is what is produced, okay? And we use these chemical reactions to describe chemical changes, okay? So atoms are getting rearranged, they're making new substances, and my reactants and my products are gonna have different properties, meaning they're gonna be different, okay? So if I look at this chemical reaction here, okay? I can depict chemical reactions in an equation, okay? We already have looked at what this is, right? These are chemical bonds, whether it's covalent or ionic bonding, okay? So that's going to continue to come up, so make sure you guys have a good understanding of the types of bonds because that continues to be reinforced, okay? But now we're going to look at, okay, if I have these two and I'm producing two new things, okay, what's products, what are reactants, right? And so I know reactants are what I am starting with, okay? Anything that is on the left side of my arrow is a reactant. So this is what I'm starting with. This is what's going to undergo a reaction, okay? So I have a solid zinc, okay, and I have silver nitrate, okay? Everything on the right side are my products. That's what's being produced. So I now have the production, okay, of a solid silver and then a zinc nitrate, okay? And so I am going to be able to depict reactions, okay, and reactant and products based on a chemical reaction. And there's certain things that are super important to understand when you're doing this as well. Is that if I have these symbols, you need to know what they are going to read as and what they are going to be like written as when you are writing them out, right? So anytime you have an arrow, okay, it's separating your reactants from your products, and you're gonna read it as reacts to form or yields, okay? A plus side is pretty much like and because you're adding them together. So this equation just with the arrow and the pluses is zinc and silver nitrate react to form zinc nitrate and silver, okay? Another thing that chemical reactions use, okay, are symbols that indicate the state of matter, okay? So we have different states of matter. You know that we have solid, liquid, and gas, okay? So SLG, okay? And then we also have a state of matter called aqueous or AQ, and that just means it's getting dissolved in water, okay? So I would read this entire reaction then from the last slide and now with this is that there is solid zinc and aqueous silver nitrate reacts to form aqueous zinc nitrate and solid silver. Okay, so that's my entire reaction there, okay? And so this is the basis of chemical change because anytime I see a chemical reaction that is written like this, I can assume that a chemical change is occurring because both sides of my arrows are not the same, okay? So something's going on, something is changing, okay? However, if I actually wanted to look at a chemical reaction in real time, not looking at the chemical reaction equation written, but instead physically see it with my own eyes, okay? There are certain indicators that are going to tell me that chemical reactions have occurred, okay? Without even needing to know what's being mixed together, what's happening, what are my chemicals, what are my compounds, what bonds are there, okay? And so these are the 4 types of indicators that we're going to be discussing, okay? If there's a formation of a solid, which we call a precipitate, that forms if I mix chemicals together, that's going to tell me, okay, a chemical change is occurring. If I have some evolution of gas, meaning it's bubbling or fizzing, okay, that means that there's a chemical change or a chemical reaction occurring. If there's a color change, okay, or if I am absorbing or releasing heat, so I'm getting colder or hotter, okay, I'm going to have a chemical or a physical change. All right. So let's look at what each of these looks like. Then we're going to watch a quick little YouTube video. Then we're going to wrap it up. It's going to be great. Okay. So this is what formation of precipitate looks like. Okay. Right over here, we have a colorless solution. We're pouring more in, and this yellow solid starts to form, right? Over here, two clear liquids coming together, and this whitish cloudy solid begins to form. Over here, this reddish solid begins to form, right? So that's the formation of a precipitate, okay? So something is forming in a solid form, okay? Evolution of gas, right? Bubbling is occurring. You can see like this, like the bubbling that's coming out, fizzing, right? So that's saying that something is happening. That's a chemical change. A color change, right? We have this piece of wire here and this clear liquid here, and it's creating this blue color. So it's completely changing a color. Okay, so that's a chemical change. Heat absorption or releasing, right? Something happened when they mixed these two together, right? They're both starting at 25 degrees Celsius, it looks like. And when they mix it together without adding any external heat, so they're not like putting it over like a stove or anything, once they mix these two together, it automatically jumps to 30. Okay. So these are different ways that I can tell without even knowing what I'm mixing together that a chemical change is occurring, okay? Other ways that I can tell that a chemical or physical change is occurring is product testing. So you have carbon dioxide, oxygen, and water and hydrogen. So we're gonna quickly watch this video and we're gonna go from there. Let's see, oh gosh. All right, so apparently this video is not working. So I will be posting this as a separate link in your notes. Please make sure to watch it. Take these notes down, but make sure to watch this, okay? So, based on today and based on what you have done, I want you to write your summary in your notes, okay? Answer the following questions. What are the differences between chemical and physical changes? Okay, you guys should know that. What are my 4 indicators and how can I use product testing to determine a chemical change? Okay, that should be singular. Okay, once you do that, we're then going to do some practice. There's going to be an online assignment via Canvas, and then there's going to be a Mastery Connect quiz. You don't have to start it now because it's going to be combined with what we do on Friday, and that's going to be due on Monday at 11:59 p.m. All right, so that is it for today.